Okay, welcome, Ruth. So we are just starting. So I'm hoping that all of you are doing fine. So I want to take this opportunity to welcome Carol, uh, who has just joined us today. So I believe, Carol, you will actually catch up with us. So we haven't done that much. We are still at introduction. So kindly confirm if you got the recordings so that you can follow along and catch up with the rest. Previously, we had introduced Excel, and we went deeper to look into statistical functions that are used in Excel. So we looked at some of them, the basic statistical functions that are actually crucial in data analysis. So we actually try to analyze or make use of those statistical functions to analyze data for sports equipment and apparel company. So we had answered some of the questions, and we had actually left the rest. So I think we shall pick it from there and see how we can use this statistical function. So this is the data that we were analyzing previously. So this data is for the sports and apparel company that specializes in selling sports equipment. So we had looked at application of various statistical functions in actually analyzing this data and actually trying to answer some of the questions that that the business owner might be asking or may be interested to know, so that he or she can make a business decision regarding the business performance. So some of the product statistical functions that we had looked at so we had looked at the count function, the count blank function, counter, count if, count ifs. So we had looked at the average. Also, we had looked at average ifs. So actually, the count function, just to repeat for your sake, the count function counts numerical values in a range of cells. So for example, when we wanted to count the number of products in the discount section, we actually use this function. So we gave the syntax. So, and the syntax was equals to count is equals to count. So we wanted to find the products that are sold in the discount section. So first of all, you start with an equal sign, and then the name of that function, then the range. So let us try to find the number of items that are sold on discount. So first of all, you type the equal sign, then count, then the range.
Excuse me, Fred.
Yes?
I don't know if it's only me, but I can't see your presenting screen.
What
Or
about the
maybe you are not
rest?
sharing your screen.
What about the
My son
rest?
can see. I can see from my end.
Kindly others confirm.
Working from my end?
It's okay from your end?
Yes.
Okay. Uh, maybe try. Maybe there might be a problem with your PC or laptop.
Let me leave, then I join back.
Okay. Okay. Sorry for the interruption. So we were looking at the count function, and we actually said it is used to count numerical values in a range of cells. For instance, we use it to find the number of items that are sold on discount. So as you can see on your screen, that is the syntax. So you begin by an equal sign, then the function. So we found that the number of items that were being sold on discount were 11. Next, we wanted to find the number of items that are not sold on discount. So we made use of the count blank function. So the count blank function counts the number of blank cells in a range of cells. So just to a refresher for that, so is equals to count blank, start with an equal sign, and then the range, so we found the number of items that are not sold on discount. There are 2. And when you actually looked at the data, we find that basketball and basketball net are the main products that are not sold on discount. The other function that we looked at was the counter function. The counter function actually counts the number of items in a cell given a particular range. So it doesn't care whether they are numeric or text. So we made use of this function by actually counting the number of items that are being sold by this business. So the syntax was is equals to counter and then highlight the range. So this business sells 13 different products. As you can see here, there are 13. We made use of also the count if function. The count if function actually is used to when you are applying condition, maybe to specific cells given a range of cells in a column. So for example, you might want to, to count the number of items that actually cost more than, let's say, 500 shillings. So you can make use of this function. So let's say we want to find the number of items that cost more than 500. So type is equals to count if, and then a comma, and then the condition now. So as you can see the result, the number of items that actually cost more than 500 shillings, there are 6 items. So when you are applying more than one condition, you make use of the count if function. So the count if functions applies when you have more than one condition. Let's take an example of how we can apply that. Let's say you want to find the number of products that are being sold for more than 500 shillings and the discount rate is more than 20%. So let's try that. Is equals to count is. So it will ask for the criteria range. So I'll choose this criteria range, this one, and then I put a comma, and then it should cost more than 500. Like that. And then we go to the second condition. So the second condition is the discount. So the discount should be greater than 20%. So that I've highlighted the range. So the discount should be more than 20%. So one thing to note is that whenever I am separating a range and maybe the criteria, I must use a comma. So sometimes you might find that your formula is not working simply because maybe you've forgotten to put a comma, or maybe you have forgotten maybe to put the quotation marks. So take note of that. So the discount should be more than 20%. So we have one item that is being sold that costs actually more than 500 and has a discount rate of more than 20%. The other function was average. So average is actually used to compute the mean. So I think this is common to all of us. For example, we might want to find the average revenue that this business generated, maybe for a particular period. So we write the syntax is equals to average, and then the revenue, and that range of sales. So we can see that on average, the business generated a revenue of 165,111. The average is function is actually the same as the average if function, but the difference is that it applies more than one condition. So you can type is equals to average if, then it will ask you for the average range. which cells do you want to average. So in this case, we want to average, let's say, revenue. For items maybe that costed more than, let's say, 250. So I'll go to cost. And had a discount rate of more than 20%. Sorry, 20%. So that is it. As you can see, it has actually returned the average of items that cost more than 250 and had a discount of more than 20%. So the other function that we want now to look at is the median. So when we are talking about median, we are talking about the middle value given a range of values. So in some instance, you might find that we are using a median instead of average. So the main drawback that average has is that sometime in your data, if you do have outliers, it might actually give you a false figure about what you are trying to average. For example, in your data, you might find that maybe there's someone in this case, maybe there's someone who is earning maybe 100,000, and the rest maybe are earning maybe between 0 to 30,000. So this figure of actually 100,000 is being described as an outlier. So when we have outliers in the data, we normally resort to use the median. So the syntax for median is equals to median let me take cost. So I can see the median is 500. You can try maybe for revenue is equals to median, then take this range for the revenue column, then close the bracket. So you can see the figure we are getting when we actually use the median, and the figure that we are getting when we use the average. So average, when we found the average for revenue, we were getting a figure of 165,111. Yet, when we use the median, we are getting a value of 21,285. So this actually is the correct value to use as your average, because it is really a reflection of what is happening in the data. So when you look at the revenue column, you can see we have an outliers. So you can see sneakers here is generating a revenue of 1,548,000. 1000. When you compare this value to the rest of the values, you can see it is actually very high compared to the rest. So this actually distorts the average. So in our case, we might resort to use the median because it's actually a true reflection of our revenue. So we found the median to be 21,285. So whenever you are analyzing your data, make sure you look for outliers. So outliers are either values that are very high and maybe values that are too low. So when you have a value that is too low, either what normally happens, you eliminate that value. So but in our case, let us just use the median. So in identifying outliers, we normally do what is called exploratory data analysis. So in this instance, when you do exploratory data analysis, you are actually trying to see how your data is distributed. Normally, we use either histograms or we use box and whisker plots to see whether our data has outliers. So for you to know where these are in Excel, go to Insert, and then under Recommended Charts, where we have histogram. Hope you can see where my cursor is. So you can either choose a histogram or you choose a box and whisker plot. So this will give you a rough idea of how your data is distributed, whether you have very high values in your data or very low values in your data. So this will give you a direction on whether you will either use the mean or the median. So let's go to mode. A mode simply means the most occurring values in your data. So in our case here, for our sports and apparel company, we want to find the discount that is mostly given to customers. So let's type the syntax is equals to mod. Choose the second one for single. So 0.1, which implies that's 10%. So most customers usually get a discount of 10%. And then we have something called standard deviation. So hope you've heard about the term standard
Fred.
deviation. Yes?
So I have a question about from the mode.
Yeah.
There were three formulas for mode. There's mode, single, and something else.
Yeah.
Why did you choose the single and not the others?
So when you are considering a single variable, for example, the mode for multiple, it means you are actually using different cell ranges. For example, maybe you might want the mode for maybe discount and cost. So you use the multi one. And also, if for example in your data you have more values that are recurring. For example, you might have 10, 10 that is recurring, and also maybe you have 5 that is recurring most of the time. So when you use mod multi, it will return all those values. That is 10 and 5. Are you okay?
Okay, yeah.
We have also standard deviation. So standard deviation actually measures the deviation of your data from the mean. So it's normally referred in statistics as the measure of dispersion. So how spread are your values from the mean? So maybe for your data, maybe to be following a normal distribution, the standard deviation value should always be closer to the mean value. So the spread should not be that much. So let us look at standard deviation of maybe the quantity of goods sold and see how diverse or how dispersed it is from the mean value. So type is equals to standard deviation. So we have two standard deviation. We have standard deviation for population and we have standard deviation for a sample. So whenever you are actually using this formula, you must be very keen whether you are finding the standard deviation for a population or for a sample. What I mean by a sample, let me use a case scenario. You have maybe you've done a survey and you have maybe 1,000 participants. So you might decide maybe to sample maybe 200 of them to be a representative of that population. So that's what we mean by a sample. So population means you are actually taking into consideration all variables that you are actually trying to examine. So in our case here, since our data is small, so we'll use the standard deviation for a population. So choose the second one. For quantity sold, we find that the standard deviation for quantity of goods sold is 294. What about if we find the standard deviation for cost? Type is equals to standard deviation for cost. We find standard deviation to be 1051. So maybe you can find the standard deviation for revenue is equals to standard deviation, standard P, highlight revenue, like that. So the standard deviation for revenue is actually 404,483. So you see it's actually differing a lot from the mean revenue, which was 165, 111. So what this simply means, it means that there is variation in revenue from different products that our business is selling. So maybe any question up to that point? Hope I'm not leaving anyone behind.
So when you've said the standard deviation, exactly what are we looking for? Sorry, I didn't understand that part.
Standard deviation measures how diverse your data is from the mean. For example, let's say your mean is, for example, 20. And then you find your standard deviation maybe to be 5. So when you compare the two values, 20 and 5, you see that difference is actually huge, a difference of 15. So for a good, let me say, a good data that follows a normal distribution, we normally say that the standard deviation and the mean, they should always be close to each other. So standard deviation simply means you are measuring the deviation or the dispersion from the mean. So in our case here, we found our standard deviation to be 10 for revenue, sorry. Let me calculate for a standard deviation for revenue, then we compare standard deviation for revenue. So we find the standard deviation is 404,483.9, and the average revenue is actually 165,111. So what this implies, it means that there is greater dispersion in revenue of the products that we are selling. And when we actually go to our data, you can find that sneakers actually generate the highest revenue of 1,548,000. And still, we have a product like basketball net that is generating a revenue of 5,850. So what this implies, it means that there is actually a big variation in the revenue we are getting from the different products that we are selling. So that is the interpretation of the standard deviation. Are you okay with that?
Okay, thank you. Yes.
Yeah.
Alfred, allow me to take you back just a bit. At
To
what point do we do the average, and then to take you back a bit on the average and the median?
yeah.
Please just explain the difference clearly.
So we use the average. First of all, let us understand average, what average is. So when you are doing average, we are actually, for example, let me take revenue here. We are summing revenue, all of it, divided by the number of products that we are selling. That is 11, or there are 13, sorry. So when you sum this and you divide that number by 13, that's when you find mean or the average. So the instance where we resort to use median is when we have outliers in our data. For example, you have very high values or very low extreme values in your data. So when you have outliers in your data, it actually distorts the average value because it will not give you the true picture of uh, your average, because there is either one value that is too low or one value that is very high. Understood?
Yes, understood.
So, okay. So let me introduce the concept of large, small, and small. So large is used, for example, to find the largest value in a range of cells, but it can also give the kth largest value in the data. For example, we want to find the second most expensive product that we do sell in our company. How can we do that? So we can do that by using the large formula. So type is equals to large. So we want to find the second most expensive product that we are selling in our company. So as you can see here, the syntax for large. So we start by an equal sign and then type large, which is the function. So it will ask you for the array. So array is the range of cells that you want to, that you actually are interested in finding the largest value. So let's take cost as our range. Then it will ask you for the kth largest value. So maybe when you want to find maybe the most expensive product, so it means the largest value in this range of cell, we'll put 1. So we'll find the most expensive product that we are selling or that cost more. So the most expensive product is sneakers. So you can see it is costing 3,000. Let us find the second most expensive product. Replace that by 2. So the second most expensive product costs 2,500. 2,500, and that is a baseball net. It costs actually 2,500. When you want to find the fifth, just replace 2 with 5. So the fifth most expensive product costs 2,000, and that is bat. Yeah. We have small. Sorry. So let us find the least expensive product that we do sell in our company. Is equals to small. Sorry. So the least expensive product that we do sell costs 50 shillings. Maybe we can find a third list. It's 150. Let's say the fourth, and so on. So regardless of what you want, if maybe you want the 10th, you put 10. So you just highlight the range and then the value that you want. That is either you want the most expensive, the fifth, the third, or the eighth value that you want to actually retrieve. Are we together up to that point? Let me know.
I have a
Would you
question.
please repeat on how to find range, the highest value?
Okay, on large.
Yeah.
Okay. You begin by tapping the equal sign is equals to large. So you will see the drop down that pops up. Choose just large. Large, it will ask you for the array. So which array do you want to find the largest value from? In our case, we want to find the most expensive product that we do sell. So highlight the cost range here. Then put a comma. So we want the most expensive product that we are selling. So there are values. K can be 1, 2, 3, 4, and so on. So we want the most expensive product. So we choose 1, or you type 1, and you close the bracket. The most expensive product that or that costs more is actually sneakers, which cost 3,000. When you find to find the second most expensive, replace 1 with 2. Find the second most expensive product cost 2,500, and that is baseball bat. Are you together, Kigana? Or have you understood?
Yeah, I've understood. Thank you.
Yeah. And then hope you've also the concept of small. It's just follow the same syntax as large, just replacing large with small. Example, you want 10. You'll find it is 2150. Yeah. Then sum. Sum, I think this is quite obvious. Everyone knows how to use sum. Sum, it means you're just finding the total. So if you want to find the total cost, the total quantity, the total revenue that we actually got by selling these products, that is quite simple. So is equals to, let's say we want to find the total cost, is equals to sum, highlight cost like this. So the total cost was 15 to 10. Let's find, for example, the total quantity. So is equals to sum, highlight that range of cells. That. You can do the same for revenue. It's just following the same syntax. The other concept is the concept of sum if. So here we are just applying one condition to a range of cell. Maybe we might want to find maybe the product that maybe costed us more than 1,000 shillings. So we can do that by using this syntax is equals to sum if. Just choose sum if. It will ask you for the range. So the range is cost. Like this. So put a comma. And then criteria. So we want to find the cost for those products that actually cost more than 1,000 shillings. $1,000. Just like that. So we found sum of the cost of goods that actually cost more than 1,000 shilling. You can do the same for maybe revenue. You might want to find the sum of revenue we generated that is actually above 50,000. So we can say is equals to sum if. We highlight the revenue, the range, put a comma, maybe 50,000, like that. So we've actually found the sum of revenue that we generated that is above 50,000. So it's actually 2,010,380. Sum ifs applies when you are when you have many conditions. So it's just follow the same syntax as count ifs, average ifs. So what you just change is the function. So instead, for example, average if, you change to sum ifs. So let us see how we can apply this. So we want to find the revenue that we generated that actually is maybe greater than 50,000, and it actually costed us more than 500. So let's try and see. Is equals to sum ifs. So it will ask you for the sum range. The sum range is revenue. That. And then let us look at the second criteria. So criteria is for the cost. So let's highlight the cost range. Cost range. Let us take say 1,500. And then quantity. Let's take quantity. So the second criterion is for quantity, that let's say quantity of more than 500. That's it. So this is actually the sum of revenue that we generated, factoring into account the cost and quantity. So in the cost, we actually specify that the cost should be greater than 1,500 and the quantity should be greater than actually 500. So now we got the results as it. So hope you can do the same for cost greater than 2,500 and quantity greater than 700. Just try that using the sum ifs formula. So cost is 2,500 and quantity is 700. Try that. Keegan, what are you getting? What are you getting, Keegan?
I'm still doing it.
Yeah, remember cost is 2,500 and quantity is 700. Carol, are we together? Carol, can you hear me?
Yes, Fred.
Yeah, so I have just given out an assignment. So have you tried it?
That's what I'm trying. I'm saying I'm trying to catch up. I
Okay.
know by the next lesson I will have
Yeah, yeah.
catched up very well.
Sure. What about Ruth?
I haven't finished yet. My machine is giving me issues today, so I'm a bit slow.
Okay, so we can just continue. So I'll just illustrate here how we do it. Allow me to share my screen. Confirm whether you can see my screen.
Yes, we can.
Okay, so is equals to sum ifs. So sum ifs, it will ask you for the range. So you highlight the revenue because we want to sum revenue. And then it will ask you for the criteria. So we want cost. So we highlight the cost range. And cost, we have said it should be greater than 2,500. Should be greater than 2,500. And also quantity is another criteria. So we highlight the quantity range like that, put a comma, and then we specify the range. Should be greater than 700. So that is the syntax. And with that, you get the answer. Yeah. So that's all about the sum if, count. So these are the functions that you will be using most often in your data analysis tasks. Yeah, I understand that there are other functions that you may actually need, but these are the ones that are mostly used. So you might find that you are using this function to maybe 80% of your time and the others 10% of your time. So let us look at something here called quartiles. So quartiles, I believe you've heard about quartiles. So what quartile does is actually it divides your data into groups. So for example, it ranges from 0% to 100%. That is from 0 to 1. So it subdivides your data into 4 equal parts. That's why it's called quartiles. Oh, yeah. So we have the first quartile, the second quartile, the third quartile, and the fourth quartile. So the first quartile is usually 25%. That's a quarter. Then we have the second quartile, which is 50%. It usually represents the median. Yeah. And then we have the third quartile, which is the 75th percentile. That is 75%. And we have now the fourth quartile, which is actually 100%. So this idea of quartiles, you might use it to have a rough idea of how your variable is distributed. So for example, you might be interested to maybe find the top 25% of your customers or the top 25% of your revenue. So that's how you can make use of the quartile function. So allow me to actually show you how you can actually understand this concept of quartiles. So drawing the box and whisker plot is the most convenient way of knowing how your data is distributed. So let's say, for example, we want to draw a box and whisker plot for the quantity of goods that have been sold. So you go to insert, under charts, under histogram, select box and whisker. So that's where you can find the box and whisker plot. So first highlight the range, go to insert, box and whisker plot. So this is what we call the box and whisker plot. So it actually divides your data into four. So let me indicate the data labels. Let me make this a bit bigger. So this is now a box and whisker plot.
Fred,
So, yes,
excuse me.
yes,
Before you go too far,
yeah,
would you mind redoing it again? I think I'm lost. I'm lost somewhere.
okay. Let me remove this.
Thank you.
So we want to find actually how the cost for our products is distributed. So one way of doing that is by using a box and whisker plot. So to insert a box and whisker plot in your data, so first highlight the range, then go to insert, I'm here, choose. So we have the option for choosing a histogram and box and whisker plot. So choose box and whisker plot. So as you can see, the way I have pointed here, you can see what a box and whisker plot is used for. So it says use this chart type to display variation within a set of data. So when you want to actually display a variation in your data set, you use a box and whisker plot. So it is also used when you have multiple data sets which are related to one another in some way. So that is actually how the box and whisker plot is used. So let me just select it. So that is it, the box and whisker plot. So let me enlarge it so that it is visible. So that is it. So let me just change the color of this so that it can be visible for you. Yeah, hope it's now visible from your end. So as you can see, we have a box, that is actually subdivided into two parts, similar like to a rectangle in some way. So you can see here it's actually divided into four. So this part here is called the whisker. You can see the one that I've just highlighted. This is a whisker. And then here at the bottom, it's another whisker. So here at the bottom, what this value means, it actually indicates the lowest value in your data set. That is the minimum value. So in our case here, it's the minimum quantity sold. So you see here it's 39. When we look into our data in the quantity sold column, we can see basketball net has the least quantity sold. Yeah. So that is 39. And then coming here to 87.5. So this is the 75th percentile. So most of our data that is actually below the 75th percentile is 87.5. So, and when you see this middle value, this is 365.23, it actually represents the median. Yeah, the median of our data. So it's actually the 50th percentile, that is a half. So it's actually 365. And then they say the 25th percentile is actually represented by 605 in our case here, where I'm highlighting here. That is actually the 25th percentile. And then here at the top, we have actually the maximum value. So what this implies is that in our cost range, so the most ordered quantity is sneakers, which we have orders what 1032. Yeah. So with box and whisker plot, you can see how varied your data is. So in our case, we have been able to determine both the minimum value, the maximum value, and also we have determined the median. We have also determined the 75th percentile and the 25th percentile in our data. So here 605 represent the first quartile, 365.230 represents the mean, 320 represents the second quartile, and 87.5 here represents the fourth quartile. So use the box and whisker plot when you want to determine the variation in your data set, or to find how your data is distributed. So let me remove this, let me cut it. maybe you can try the same for the cost, so that you can see how varied your cost is for the different products that we are selling. Insert here, choose the box and whisker plot. Let me enlarge this. Let me put data labels. So when we are actually seeing here the cost, we can see the maximum value is 3,000. The minimum value is 50. The 25th percentile is for the first quartile is 2,325. The second quartile is actually 500, and the third quartile, which is the 75th percentile, is 200. So what this implies is that when you see this box and whisker plot, and you compare with the first box and whisker plot that we plotted earlier, you can see there is a lot of differences. So here we can see this value, that is can you see where the 500 line mark is passing from your end? Or maybe I can highlight it so that you can see it. I'm talking about this line. Can you see it from your end?
Yes.
Yeah. So it means actually there is more variation from the mean. So our mean actually is 1170. But when you see the distance between the mean and the third quartile, you can see actually that difference is actually big. So what that implies, it means that the cost for different products are actually varying a lot. When we try to compare this box and whisker plot with the one that we plotted earlier, the one that we plotted earlier, there was no huge variation within the quartiles. So you could see that this line is closer to the mean. So it means actually the standard deviation is actually closer to the mean, and the variation is not that big. So that's all about the box and whisker plot. So let's go ahead and see how we can calculate the quartiles. So let me say that I want to find the first quartile of maybe our revenue. So we'll type is equals to quartile. And then highlight revenue. And then it will ask you for which quartile do you want. So we have first quartile, we have the second quartile, which is the median, which is the 50th percentile. we have the third quartile, which is the 75th percentile, and then we have the fourth quartile, which actually gives the maximum value. So let us say maybe we want the first quartile. So choose one, then close the bracket. So our first quartile for revenue is 9,500. So let's try and see the second quartile. So this is first quartile. Sorry. That is first quartile. Let's say second quartile. So type is equals to quartile. Highlight like this. Close the bracket. Third. Third quartile is equals to third quartile. Choose that. So it is 86,800. So the fourth quartile actually gives the maximum value. Fourth quartile is equals to quartile. To give you the maximum value. So as you can see, the maximum value is 1,548,000, which is actually true when you confirm from the data. You can also choose the minimum value, so that is 0 quartile. It will give you the minimum value is equals to quartile. So 0 give you the minimum value. So as you can see from the data, the minimum value is actually 29.50. So that's all about the quartiles. So they're just used to group data into groups, and you can actually group the data into 4. That is from 0 to 1 or 0% to 100%. So maybe any question up to that point before I switch on to the next subtopic.
A question.
Yeah.
The bar and whisker.
Yeah.
Do the name vary from one PC to the other? Because I can't find it from my PC.
Really?
I can't find it.
Just go to insert. And you see where we have recommended charts. Go to where we have Hope you can see where my cursor is. We have where we have a scatter plot and then a histogram. This is the symbol for histogram here. Then click there, and then it will give you the options to choose the box and whisker plot or the histogram itself.
When I click on that,
Yeah.
I'm getting a 2D column, a 3D column, and more column option charts, and it's not there.
Okay, maybe let's share your screen. Maybe I can see.
Okay.
What about the rest? Can you find the box and whisker plot from your PC or laptop? Kindly confirm. Okay. Let me stop sharing. Sorry.
Fred,
Yeah.
you're using which Excel?
Mine is 2016.
And I'm using the same, and also on my side I can't see it.
Maybe it's the version. Maybe have you updated the features?
No, I haven't.
Maybe that could be the reason.
Okay.
Yeah. But if you're having the recent version of Excel, you should be able to find it.
Okay, maybe I'll try and update because also I'm not seeing it. I'm having funny things here. I have waterfall stock chart. I do have insert hierarchy chart.
Okay.
And then column and bar, but it's not there. And that is box and whiskey is not there.
Yeah, I can see your screen. Let me play it.
So sorry.
What about when you click where we have is it the scatter?
Here.
Okay, it's not there. What about go to the next tab? Go to the other one. It's not there. What about this? Yeah.
Where?
Yeah, where you are. So I see actually maybe it's your version of Excel. Maybe. Yeah, it's not there. So maybe update your Excel. Maybe it doesn't have the recent features.
Okay.
Yeah. So we want to move on to actually another different thing. So we want to talk about correlation. Have you ever heard about correlation? Caro, have you ever heard of correlation?
Yes.
Yeah. How about you, Keegan, and the rest? Hope you've all heard about correlation. So we've all been doing it in campus when we were doing statistics. So, Caro, what is correlation? anyone with an idea?
Oh, sorry, I was omitted. I'm saying it is a mutual relationship
Yeah,
or maybe a connection between two variables or more.
yeah, exactly. So correlation is used actually to measure relationship between two variables. So it actually ranges from -1 to 1. So we might have maybe a variable is positively related to another one, or it is negatively related to another one. So in statistics, we normally have a way to distinguish between a strong correlation between variables and a weak correlation among variables. So the point usually is if your correlation is lying, for example, between 0 to 0.5, so it means that the relationship is actually weak. And if it's more than 0.5 to maybe 1, it means that the correlation actually is very strong. So in our sports and barrel company, we want actually to see if there is actually correlation between the number of products or the quantity sold and the discount being given to customers. So our hypothesis is we expect that whenever we are giving discount to customers, we will sell more products. So we want to examine if that is the case, if actually the variables are actually strongly correlated or not. So we are actually trying to measure the strength of the relationship. So let me share my screen and demonstrate how we can do that. So before you do a correlation analysis, the first thing that you should always do is to examine whether those variables are related. So in our case here, we want to see the relationship between the quantity of goods that we have sold and also the discount. So are these two variables related to one another? So we can find the relationship by drawing a scatter plot. So just the procedure of inserting a scatter plot. So let us highlight the range like that. And then go to insert, charts. So you choose scatter. So this is the scatter plot that we have just plotted. Let me enlarge it so that you can see it clearly. So you can see how the dots are distributed. So in the x-axis, we have the quantity sold. On the y-axis, you have the discount. that has been given to customers. So does if we increase the discount, does it really imply that we sell more? When I see when my discount is at 10%, we sell roughly around, let's say 150 products. Yeah. When the discount rate rises to, let's say 20%, we sell 250. Yeah, this point at the mid. When the discount rate we increase to maybe say 40%, you see in the x-axis we sell over 600. When it's about 55% or 50%, you see we sell the most. So this gives a clear indication on how these two variables are related. So let me put this here. So you can see now the discount rates. So when we give a discount rate of 50%, we see we sell over 1,000. So this indicates that there is actually a relationship between these two variables, and we can now go ahead and do the correlation to see how these two variables are related. So we want to get the measure of strength of these two variables. So let me remove this graph. So now let us find correlation. Correlation. So is equals to correl. This is correlation. So it will ask for array 1. So array 1 will put sorry. We'll put quantity, and then array 2 will put discount. So we find the correlation to be 0.87. So in the scale of 0 to 1, this is greater than 0.5, and we can actually say that there is a strong positive correlation in quantity sold with regard to the discount given. So the more the discount we give, the more we sell, as illustrated in our scatter plot. So we've actually found that correlation. So we can actually say that the business owner of this sports and apparel company should continue giving more discounts to customers so that they can sell more. So there is a strong positive correlation. So if this value could be less than 0.5, we could actually say there is no or there is weak correlation between the quantity that is being sold and the discount. But in our case here, we see that there is a very strong correlation. So that marks the end of our analysis of the sports and apparel company. So it says sports equipment. So we have actually used the statistical functions, beginning from the very basic functions to intermediate functions like correlation, standard deviation, quartiles, and so on. So I believe by now you've actually seen how you can use these functions to actually analyze your business performance. So maybe if there's any question up to that point or any comments regarding how the sessions has been, we do value feedback so that maybe we can improve in future. So any question regarding our today's class or lesson?
Maybe, Fred, for me, I'd request the session was a bit engaging today. And I had issues with my computer before. Is it possible to share the recording soon so we can go through it tomorrow? I can go through it tomorrow morning just before our next class. If you don't mind.
Yeah, I can share. But
Yeah, before. Yeah.
the main problem is usually the file is usually big, so it's impossible for me to share via email or WhatsApp because the file is quite big. So I was requesting if you can install AnyDesk app on your laptop. So with AnyDesk, you can access a machine remotely. For example, I can access your machine from where I am, and maybe you can copy the recordings, but I'll try as much as possible to generate the URL so that I can send it as a link. So when I send it as a link, it will direct you to YouTube, where you might be prompted to use your data bundles to see the recordings. So which do you prefer?
I think it is okay, Fred, on my side. If you create any URL,
Okay.
because it will help. Yeah.
Okay. So the
That is on
session.
my side. What about the rest?
So what about the rest?
I'll be okay with the URL also.
Okay.
Me too.
Keegan?
Me too.
Okay. So thank you very much. So we've come to hello,
I want
Winnie. Winnie.
yeah, I wanted to request like the same, maybe using the same analysis or like the same Excel that you are having.
Yeah.
Is it possible you come up probably with different questions of the different functions for practice, or is there like do you have anywhere probably on the net where we can get such with questions for practice?
Okay. These questions I normally, out of inquisitiveness, I normally compose them so I can just come up with a data set. So I'll share that data set with you.
Okay.
So I'll come up with actually thorough questions regarding what we have actually covered so that it can enhance understanding.
Okay, thank you.
Yeah. But tomorrow we have the same session regarding the same functions that we have covered. But tomorrow now we are analyzing a different company. So we'll have a data set for a company that is selling motorbikes, that is motorcycles, and its accessories together with its clothing. So we have a huge data set of about 60,000 rows. So we will be using the functions that we've just learned in Excel up to today to see whether we can actually come up with amazing insights from that data that we can actually present to the board of management so that they can make business decisions. So I think that will also enhance your understanding. Ruth, you were talking?
No, I'm good. I just, as you said, the URL is okay. I was just requesting if we can have it just before tomorrow's class so that I can go through. I was kind of floating at first.
Okay.
Yeah.
Okay, you'll have it.
Thank you.
Yeah. So I'll be giving you tomorrow. I'll give you assignment regarding what we have covered. So I'll go and research and come up with questions that will cover the functions that we just covered. Is that okay?
Yes.
Yeah.
That's okay.
Okay. So I just want to wish you a lovely evening and nice supper to you all. Goodbye. See you
Thank
tomorrow.
you. Okay,
Bye.
bye. Thank you.
Bye.